how's it going, everyone? Okay, today we're going to talk about tracing and understanding service dependencies a little bit. Okay, raise your hand if you have ever had your service fail due to a dependency failing. Okay, good. Good. We're in the right place. Cool, this is a pretty common occurrence. We work in a complex world of distributed systems, and failures happen all over the place. And sometimes they're hard to track down. We have many different observability tools to help with this, tracing being the one we're going to focus on today a bit. And we can use them to track down these types of failures, but is there anything we can do to make this easier? Is there anything we can do to make this better? First, for any of those of you who haven't had the pleasure of experiencing something like this before, we're going to see what this looks like in a little bit of a simplified example. Okay, so say we have a house. A house has got plumbing fixtures. We've got a decent understanding of the freshwater input and the drainage output. We have different fixtures around the house that have connections to these, but we don't necessarily understand how things are connected within the house. So what happens if there's a problem? Let's say 3 fixtures suddenly can't drain all at the same time. They don't appear to be connected in any way, but they all stopped working, like I said, around the same time. What would be helpful in understanding what's going on here and figuring it out? We know we can, like trace, send a snake down one of the lines and trace it all the way down until the failure, but we don't know the best place to start, and we don't understand how everything is connected here. So what would be helpful? Well, a map. Now we can see the interconnectivity here. Now we can see how these pieces all go together, and we have a better understanding of the greater picture of the system. And we can see that these 3 failures are really just one failure further upstream. Okay, so to build a simple picture like this, we just said we can snake out lines and trace each one individually. And that works for a small house with a few fixtures. But what happens if we scale this up a bit? So at Coinbase, coming back to the software world, we're looking at a lot more data. We're looking at over 2,000 different services that are calling one another. We're looking at over 760 different user journey steps. And this average projects per user journey step, that's per step, not user journey. So a user journey like buy crypto could have hundreds of different projects that it's touching. Okay, so we're not just talking about a few fixtures now. We're talking about a lot of different services. So clearly we need to automate this process. If we can do that, we can build our own version of this map, and we'll call it a service graph. And then we can leverage that to help us automate the root cause analysis process. So we're going to build this graph, and then we're going to use this graph for automation. Cool. Hi, I'm Eric. I'm a software engineer at Coinbase, focusing on observability and operational excellence. I help teams understand the reliability of their services. And outside of work, I love spending time outdoors. Today, we're going to be talking about a lot of different work, though. I have done some of it, but a lot of this stuff was done by my colleagues on the observability team, some of which are here today, as well as colleagues on our developer experience team, our data platform team, our consumer engineering and testing infrastructure team, and more. And also some work done by our partner at another company called PuppyGraph. So a big thank you to everyone involved there, and just want to make sure to give credit out to all the other folks that have been working on this awesome stuff. And we're Coinbase. You may have heard of us, but if not, we're a crypto company. Our mission is to increase economic freedom in the world. Increased economic freedom, which includes free trade, property rights, stable currency, and more, is the foundation for many other important freedoms, and it's the way that we believe we can make the biggest impact. And Coinbase is how the world uses crypto. So these are, to give a little bit of a sense of scale of Coinbase, we have over $330 billion worth of assets on platform, over 100 million verified users, over 250 assets available for trading, and are operating in over 100 countries. Okay, in addition to these metrics on here, Coinbase also scales to support over 2 million concurrent active users. So now we've done a little bit of introductions here. Let's get back to the problem at hand and dive into a real-life example that we had in an incident. We're going to have some things anonymized in here, and this is not to call out or shame any particular service or team or anything like that. It's just to highlight a gap that we've had that I think some others might be able to relate to, and how we've been working to fix that. Okay, 8:26 a.m., a team opens up a low-severity incident on product eligibility service, which controls access to various Coinbase products. There seem to be intermittent issues with the service, but nothing super alarming to the team that's opening up this incident. And for reference, what you're seeing on the screen is what will show up in the incident channel shortly after someone opens up an incident. It'll give an overview of what they provided on the incident. It will give kind of at-a-glance information. It might also show other high-severity incidents that are happening if there are any happening at the same time. But a pretty standard thing right here, just starting out. OK, so we're tracking this issue. So about a minute after this is opened, we get a ping from our customer experience incident response team to check if this is a user impacting incident, which is actually really awesome because this is a SEV 4 out of 5, so it's a pretty low severity incident, generally not something that would have major impact. But they know that this service might affect customers, so they're pretty quick to check and see what's going on. Now, unfortunately, pretty quickly after that, we see that we don't know what the story is. We do not know what the impact is. This is not the response you want to see. We have an outage in a service going on, and we do not understand what is happening for our customers. So what do we do? How do we figure this out? Well, let's look at what else was going on around the same time as this incident. A few minutes after the first one opened, we got another one opening saying that customers are unable to access the staking section of the page. Shortly after that, we're seeing that customers can't access the borrow product. And that graph shows our borrow product usage dropped to 0. We start seeing teams reporting that their services are affected in the original incident channel. Things do not feel organized right now. We are getting pings coming in from all over the place, incidents getting spun up, and then we ultimately get reports that this is what our Coinbase 1 page looks like when people try to load it. So I guess you could say there was customer impact. It was not immediately clear that these were all one incident and that they were all linked together, hence the other incidents kind of getting spun up in the first place and not all going in that first incident channel. But eventually the teams did figure it out. About an hour and a half after the incident was opened, a little over, we finally actually had a full picture of the understanding of customer impact and were able to report on that. Now, thankfully, throughout this time, different teams were debugging, working on it, found the issue of a recent configuration change, and were able to fix it. But it took a really, really long time to understand what the impact was here. And that's a problem, because we need to be able to fix these things faster and understand it more quickly. So there were many important learnings from this incident, but today we're really going to focus on one. How can we quickly and easily understand the causes and effects of service failures? And breaking this down, what are the things we care about? How can we better understand our network of microservices? What can we do to expedite impact identification? And how can we quickly determine when one service is ultimately causing another one to fail? OK, so let's start with tracing. We have this as an extremely powerful tool. It provides insight into every step of the request. So we're looking at a trace here. We can see all the different steps, the spans involved. We can see the services involved. We can walk through the entire request. This is a really powerful tool. But it gets overwhelming extremely quickly. This is the exact same flame graph as on the last slide, just zoomed all the way out. This was also not targeted. This is not a trace that I went hunting for a purpose of demonstrating how overwhelming it can get. This is a random trace I grabbed. Literally, it's the first one that I grabbed. And it has 641 spans in it. Now, all of this is to say, even if you have not already spent a bunch of time in APM, please go do that. Tracing is awesome, and Datadog has some awesome tools to make this easier within Datadog itself. And it has a great map view. It can identify various services. It is a powerful tool. So this is not to knock APM, but there are certain things that maybe we need to do a little bit better. And one other thing we should be able to see from this that's really, really helpful is that because we have this trace data, because we see all the services involved, we actually do already have an automated way of understanding service A calling service B calling service C, et cetera, and seeing that whole chain. It is the trace. So we just need to figure out how we can leverage this information better in incidents. OK. How do we do that? So if we're talking about building a service graph, which is a big topic here today, there are two parts of a graph. There are the nodes and there are the edges. So if we're going to start with the nodes, we'll talk about the projects and services in the graph. So this is a snapshot of our ownership registry. It's a taste of what that looks like. It has definitions for all of our projects and services we run at Coinbase. It's got some metadata on those projects. And it's also got information on the on-call and the directly responsible individual or owner for the project. And what's really important for our discussion today is this bidirectional mapping between projects and the folks who own them, i.e. the teams who own them and the directly responsible individuals. And those really represent the nodes in our graph. And we're going to see later on why we need this mapping and why it's really important to have this solid understanding of ownership throughout this process. But just keep in mind that this is what we have going in. And these represent our nodes. OK. So as we discussed earlier, tracing is what is ultimately going to link these pieces together, and that's the data we're going to use to build these service connections. But I'll take a brief opportunity to share with you all the scale of observability data at Coinbase and what that looks like, and what our logs, metrics, and tracing data really looks like on a per second and our peak basis, as well as what storing a year's worth of our unsampled tracing data looks like. It's a lot, and we need to collect this data, and then we need to build it into a graph. So there are a lot of steps in that, and let's take a look at what that looks like. OK, so we're going to focus on trace collection right now, and this is going to be mostly for our web services that run in Kubernetes, as that is our most common paved road at Coinbase. We do have other trace collection mechanisms, but this is probably the most common use case we have, and it's the one we're going to really talk about today and dive into a little bit more. So looking at this, we have web services running in different Kubernetes pods. They're going to be generating traces with a tracing library. Those are going to get picked up by the Datadog agent, which is going to send them to our Datadog cluster agent. And our Datadog cluster agent is ultimately going to be sending that information onto Datadog. So this is the first version of our trace collection that we did. We're going to show the next one in the next slide. But when we were doing this, we decided first to try to collect traces from where we already have them, which is obviously Datadog, since we're already sending them there. We built an Airflow job that would run twice a day, and it would start pulling traces from Datadog using the spans API. This worked. We were able to pull spans twice a day into Snowflake. We ended up being able to pull about 1 million spans per day in 2 different sessions. But as you just saw on the previous slide, that's not a lot in the grand scheme of how much we're really collecting. Because this had its limitations. And this is not to knock the Datadog API in any way. The spans API was just never designed to bulk export all of our spans. Datadog is made for ingesting them and getting spans and seeing spans and traces inside of Datadog, and for individual collection or collection on a basis as needed. But we were trying to bulk collect as much as we possibly could. So that was one big limitation, was that we had extremely sampled traces in Snowflake because of that. So when we're leveraging metadata on traces and need certain traces that will only certain traces will have certain pieces of data, when we're sampling to such a large extent, we're really losing a lot of data from different subsets that we care about. And then the other limitation was the fact that because this was running as a scheduled job, this would only collect traces at certain times of day. So if you had other scheduled jobs that weren't running during collection periods, or just for whatever reason certain requests weren't captured, we'd completely miss that. So there were some gaps in this that we wanted to improve. And we took this a step further and evolved a bit. So this is the next version and what it looks like a little bit more today. And largely, traces still get to Datadog the exact same way they did before. But instead of trying to pull traces from Datadog, we started pushing traces to our data store. So in this case, we are dual shipping our traces from the agent itself. And we're dual shipping them, one to Datadog, as you would expect, and then the other place is to this Datadog shadow that's listed on there. And that's a facade API that was spun up by our data platform team that will collect traces and ultimately send them to Databricks, where we store them as well. And that's our dual shipping method. And then you're going to see what we do with them in Databricks. And we're going to also see how we then query those with PuppyGraph and how we leverage PuppyGraph to make this even easier. So now we have our nodes, which were the projects that we talked about before. And now we also have our edges, which is that tracing data stored in Databricks. Let's dive in and take a little bit of a closer look at what that tracing data looks like and how we can transform the raw tracing data into this graph. OK, so this is what some data entries look like in Databricks. Apologies that they're a little bit long, so we had to go on a couple rows. But we're going to see 1 through 9 in the top chart and 1 through 9 in the bottom chart. The number rows are the same on both. So 1 corresponds with 1 on the bottom. It's all one row, just extended too long. And what we're going to see is some of our trace data right here. Each line entry here is a span. We've got service level information, resource level information. You can see everything here is part of one trace with shared trace ID. You can see the different span IDs and the parent IDs that are used to order these and construct and build them into what will be a tree, which we'll talk about in a second. We have some timestamp duration information, some metadata, and that metadata is where we'll pull out some other key linking information we're going to talk about momentarily. But here what we really want to look at is we care about these IDs. And what we can do with this is while these are flat entries in a database, we can really think about this as a tree or as a bunch of different trees where each trace is essentially one tree. You have your root span as the root of your tree, and then you have all the other spans as the different nodes or ultimately leaves, and build this out. So when we have a bunch of trees in this case, we want to then flatten this into a service graph. So what do we really care about? So we care about, obviously, the projects we talked about earlier. So how do we get that? We use the metadata and some of the other fields in this to join this information with ownership registry, like we talked about before. And then with the project level information from ownership registry and the tree structure that we have here, we will take distinct pairings of service A calling service B and keep that as a record. So now we have these distinct pairings of service A and service B that become the building blocks that go into our graph building. So in this case, we're going to see this is the joined data. This is the joined data with project and service level information, where we have the ownership registry level information combined with some of the tracing level information. And we're seeing this is all for one project that I pulled out from the last slide. This is all for our entry gateway project. And you can see several projects that entry gateway calls in this example here. And this is a sampling of the table that goes directly in to PuppyGraph to build our service graph. So how do we then use this there? So what is PuppyGraph? PuppyGraph is a graph query engine. It empowers users to seamlessly query one or multiple data stores as a unified graph model. In our case, we're using Databricks. PuppyGraph's strategy provides compute and storage separation. So in our case, we can use PuppyGraph to analyze this data in one way that we're about to look at. But we can also use the data as is in Databricks for several other purposes. And we're going to see multiple different use cases. First, we're going to talk about root cause analysis using this. And then we're going to talk about some other use cases that we have and other ways we actually are able to get more information from this data. Yeah, and PuppyGraph is one of the key pieces that enables this for us. So this is a high-level overview of what visualizing the data in PuppyGraph looks like. This is a graph sampling, so this is not a specific query looking for something right now, but it's an overview of what the graph can kind of look like. But again, just samples of about 105 nodes and 100 edges, as it says there. This shows our total number of nodes and edges in the graph, and we can see our count of services and projects that were mentioned earlier. And this is giving like a high-level taste of what that interface looks like. Again, viewing it as a directed graph, being able to navigate through it, and getting a real understanding of how different pieces are connected. Okay, so this is an overview. Let's look at how we then leverage this data in root cause analysis and how we kind of put the pieces together. So what we're looking at here is our root cause analysis bot and how that's put together. So the root cause analysis bot really unifies some of these pieces that we were talking about, and it's in the center, and we're going to kind of work our way out from that. So when we have incidents, they're created in incident bot, and RCA bot will pull incident bot, and it will find new incidents as they're created. When it finds a new incident, the first thing that it will do is it will try to see, for the person who opened that incident, who knows something went wrong, do they have any recent pages in PagerDuty? If they do have any recent pages in PagerDuty, are those associated with a Datadog monitor? Is that Datadog monitor tagged with a project that's in ownership registry? That's our starting point. If at any point we hit a wall there, we don't have a page, we don't have a monitor, we don't have a project on the monitor, we start with ownership. And this is, again, why that ownership registry is so important. We start with what are all of the projects owned by the team of the person who opened the incident? And those are our starting points. That's where we want to look at, because we know that something owned by the person who opened this incident is probably broken. So okay, that's our starting point to search. the next thing RCA bot will do is call puppygraph. So in addition to the graph-based visualizations, we can also directly query and do graph queries through puppygraph and get the list of all the dependent projects up to a certain depth from the starting set of projects. So whether it's the one project from the Datadog monitor or the set of projects that they own, we'll then look for all their dependencies up to a certain depth in puppygraph. And now we'll have a larger list of projects that will be our kind of, our basically set that we're looking at that might be the root cause. And we're considering all these projects as ones that we really want to kind of get more observability details on. So the next steps that the bot will take are getting information on all of these projects. So it'll be fetching from Datadog, it'll be fetching from other data we have in Snowflake, and what it's going to be trying to figure out is it's going to be getting recent config change and deploy events for all these dependent projects. It's going to be getting SLO performance changes for all these projects. It's going to be getting error rate changes for these projects. And then it's going to put all that together, and it's going to try to assess and with some level of confidence recommend which project or projects it thinks are related as the root cause. Awesome. So let's take a look at what that looks like in an incident. So when I'm going to go create an incident, I'm going to go open a Slack channel. That's how we do things at Coinbase. And I'm going to type /incident, hit enter, and I'm going to be greeted with this. It's going to let me know to check if there are any other incidents. I'm creating a test incident for the sake of this demo. So there's nothing that I need to be worried about to check right now. So I'm going to go ahead and click New Incident. I'm going to try to click New Incident. There we go. OK, this is the new incident screen that comes up in that case. And this is actually what generates that Slack message we saw earlier on in the first incident. So it's really important to put in all the key details that you have here so that when anyone's reading this, they'll understand if your incident is really relevant to them and if it's probably the cause of what's happening in their service. But this is where you'd fill out that basic information. And when we hit submit on this, it's going to trigger RCA bot. OK. So what does RCA bot give back? So I'm not going to run it for this test incident. I'm going to show you what it gave back for another incident. So this is the header message that comes back in Slack from RCA bot. It's got a nice attention grabber to it. And you can see just basic high-level information on the first measure of the incident. It's got the incident name. It's got the severity of the incident. It's got the channel where the incident's happening. And it's got the owner as well as a list of people who've been active in the Slack channel. We also start considering those people in RCA bot as well as when incident ownership changes, there's other triggers. So it's also helpful to have other information about who's involved and who's debugging in this incident. And then where do things get really interesting? We're going to take a look at the thread. So the thread in this message, each line is one potential recommendation. So what we're looking at here is we've got each line, we've got a project up top. We've got the confidence that it thinks this was the root cause. We've got the SLO percent change. We've got the error rate change. And then we've got events. And what's also really nice about these is they're all linked. So we can go directly in, see more information of the project, see the Datadog page for the SLO, see the Datadog page for the error rate change, and see a Datadog query to see recent events that may have triggered, or from deploys or from config changes that might be affecting this. This is super helpful. If this goes into the incident channel very quickly after you opening, it gives you a starting point. It gives you a place to go look and see, is this really the case? Is this what's happening? It also helps you rule things out quickly. It checks a lot of the key things you would want to check anyway with respect to how are these different services performing. And this is just one way we can use this tool. So this is the automated way and how we can automatically check for things when we open up an incident. But we can continue to leverage this data in other ways. So another way in an incident where we can use this is kind of a manual search using puppygraph and using that query interface. So in addition to that automatic lookup, what we can do is, we were talking about product eligibility service earlier and trying to understand the services that are affected when it goes down or has issues. So what can we do today that we couldn't do before? Now we can run a simple query in this graph-based, or a simple graph-based query in puppygraph here. And we can say, we can get information using a simple query like breadth first search here to get dependencies on this service and understand what services call this. And if this is having an incident, and we can check up to a certain depth or however we want to do it, which services might be affected and Who should we be reaching out to? Who should we be notifying, et cetera? OK. So how else are we using this data? We've talked a little bit about some root cause analysis techniques that we have from this with RCA bot in this puppy graph here. But we have other use cases beyond RCA as well. So in addition to the root cause analysis, we're using this tracing data to understand which projects are underpinning our critical user journeys and which software projects are part of which business products and how that, and we're able to get a much better understanding of this picture with this data. And basically what we're seeing on this slide here, up top we're seeing an interface in Datadog traces showing different traces that are tagged with user journey step information. And what we're seeing on the bottom is kind of a final product of a lot of our work here and some of this aggregation. And what that is we are using the same trace collection mechanism that we talked about earlier, the same project mapping that we were doing earlier, and then using the metadata about these user journey steps to understand which projects underpin which critical user journeys. Then what we do is we will take the projects that underpin those user journeys and get all of the SLOs for those projects to understand how they're performing, and then aggregate that information into reliability over time for each of the different critical user journeys. And that's what we're looking at here. And that's what that bottom chart represents, is that aggregate representation of reliability of different critical user journeys based on the SLOs of the underpinning projects. Oh, and one note about this is that this is in addition to tracking user-facing errors. I think most of us know that the most important thing to track is seeing what the user is seeing, and when they are seeing errors, able to capture that and understand what that looks like. This augments that. So even when users are not seeing errors, this can help us catch things like retry storms or lack of scaling much more quickly. And we can catch this in backend services even when the users aren't seeing any failures. OK. Yet another use case we have for this same data. This is coming from our data platform team. They use this to extend data lineage. So data lineage tracks how data moves around within our data stores. Things like how certain columns are used from one database and put in other places. But it's now been extended to track the services that write to various data stores and ultimately the services that call those services. And this is really helpful for things like data governance, but it's also helpful for understanding how an upstream failure can affect data quality downstream. And what do our next steps look like for this? So we have a few next steps that we're considering and also working toward actively in different areas. A few that I'll call out here is I'm using a weighted version of this graph to get a better understanding of relative service load and how often service A calls service B. We are looking into extending this to track end-to-end test coverage. So just like we understand which critical user journeys are powered by different services, we can similarly get trace tagging with end-to-end test information and understand which projects are ultimately getting hit and tested by which end-to-end tests. So we can see that the end-to-end tests are actually getting where they need to be going, are covering certain projects, and we can also make sure projects are getting covered by tests that way. And then we're also looking into increasing our granularity of this. So we've been talking about projects and services, but we can even go further and track at endpoint and method level to understand which functionality of which projects and services depend on one another. But your next steps might look a little bit different. Not everyone needs to spin up all of this tooling. This is Datadog Service Map, or as I think recently, internal developer portal. And no, Datadog did not pay me or ask me to highlight this. When we started this project, Service Map was much less developed, and we also have certain quirks, somewhat how we use environment and certain expectations on other tags that unfortunately don't quite match up with what Datadog needs today. So we couldn't quite leverage this for some of our use cases, but that doesn't mean you can't. And it is right there, ready for you, also building on top of APM-related data. So this is, for many of you, probably the most straightforward solution if you're not trying to go into alternative trace collection or pulling out different traces. It doesn't always get you some of the linking that we've been doing here. And we've obviously gotten a lot of different benefits from what we've been doing, but I wanted to make sure to share this with you all and highlight that this is a great place to go check things out beyond checking out APM, going further into Datadog IDP. Yeah. So now we can easily visualize service interconnectivity and automatically detect dependency failures. Unlike at the start of this story, we can quickly determine which user journeys are affected by a particular service being down. We have a high-level plumbing map of our different systems. And we're working toward understanding things even more granularly. We also have ways to automatically check dependencies for failures when an incident spins up. This was our journey. It is still very much in progress. And I hope I was able to share at least some of the things we learned along the way with all of you today. Thank you, Datadog, for inviting me to talk today and for all of your help getting this presentation together. I really, really appreciate all of your help and support and helping making this happen. And thank you all for coming and listening today. Now I'll open it up for any questions.
Hey, I had a question. When you pull the span data, and that kind of informs all the dependencies and the connections, how does the bot kind of know if things changed in the background? Like how far back to look for historical analysis or knowing when something is moved over?
Yeah, so when it comes to the service graph right now, we build it on a daily basis. So we essentially only have a live version of the service graph at any given time. But that's a great question, but we do update it every day. So there's only one version available to the bot at any given point, but good question.
I have a question. Were you able to answer the question of, is this user impacting faster now that you combined all this data?
Yeah, absolutely. So in particular, the two pieces that I think are most helpful for that are the user journey linking as well as the visualization in PuppyGraph for querying there. So basically the two pieces of that, one, the critical user journey linking will basically give us a direct answer as to if a given project is underpinning a particular customer behavior that we track. And that will almost immediately be able to tell us whether or not a particular project having an issue likely will affect certain features. And then the second piece of that is kind of the PuppyGraph query part that I was trying to show, where you can directly query in the graph interface, like a breadth first search of for starting a given project. You can see what calls it or what it calls. So you can get a better understanding as well of the projects that depend on it and what it depends on.
All right, great. Thank you.
No problem.
Hi, great talk.
Thank you.
It seems like you have a really cool system for tracking ownership of projects, but I'm kind of curious, as you document and maintain ownership of user journeys, user journey steps, how does that look? Where do you document it, and how does it then feed into all of your trace information?
I'll say also a solid question. For critical user journeys today, the way we've been tracking this information actually is from it's almost a technical approach as opposed to a business level approach. From the standpoint, obviously we need business teams involved in helping define what these journeys look like. But the way we collect and keep journeys up to date today is that they're defined in our front-end code. So we go to the front-end code repositories and they have defined user journey steps, and those are composed then into journeys. And there are marks, and this is kind of what I was mentioning, that our developer experience team added a cool feature. So there are marks in the front end, and when you add these marks in your front end code, and basically what ends up happening is that there's a start mark and an end mark for each user journey step, and any time you are between those marks, your traces will get tagged with any relevant active user journey steps. And what we do is we'll go into that front end code repository and we will parse out those user journey definitions every day and store those into Snowflake so that we can use this in these mappings. And we'll get an up-to-date list of what all the different user journey steps are on a daily basis from that. So that as long as basically whatever's getting emitted from the front end and whatever's being written there by those folks, we'll collect that and be able to track that.
Excellent. And then once you gather the data from the front end, I'm assuming you don't necessarily pass it down as you're going multiple layers into the call stack. You're just able to use the graph to figure out where you started and ended? Yeah,
you got it. So it's the root span of the trace will get tagged with the information, but the rest of the spans won't. So we can use the trace ID to be able to link that together and propagate that information.
Awesome. Thank you.
No problem.
Hey, that was a super novel approach to how you're making sense of trace data, so thanks for sharing. My question is around trace sampling and cost management. Could you speak a little more about how those factor into this project and if you had to make any changes there?
Absolutely. So there are a few different considerations on this. There's trace sampling in a lot of different places, and what was nice about this approach is that because we're dual shipping directly from the agent, we are able to avoid all but client-side trace sampling in this collection today. We absolutely could increase sampling if we were more concerned about data store costs, because obviously the biggest cost in this is everything happening on the Databricks side and getting that data there. And we could increase sampling if we were concerned about that. We're somewhat comfortable where we're at right now with what we're collecting, but I would say that that's where sampling would come into play if we wanted to do that. We could do that very easily directly in the agent, versus in the issue before we're having is we were just not getting enough data to be able to effectively map what we needed to, whether it was critical user journeys or eventually testing data. The amount of spans we would get with relevant metadata would be so few in the million that we would collect that it would take too long to be able to update that, and like the daily charts would not be accurate.
Thank you.
No problem.
Hey, so I'm curious how you landed on the confidence score for the RCA. And then second question is like when you look forward to something like Bits AI, where Datadog is providing their own RCA capabilities, like how much of your confidence score is based on proprietary data that Bits AI would not have access to?
Yeah, this is a great question. I wish I had a better answer for you right now. Unfortunately, I'll have to refer you to my colleague for a better answer on exactly where that confidence score comes from. He was he's actually here in the front here, but he can give more information on where that comes from in RCA bot. And yes, so I will definitely share that obviously we're here at Datadog Dash. A lot of stuff that Datadog announced yesterday is naturally, I think, stuff that an observability team like us or at a lot of other companies probably overlaps heavily with a lot of stuff that we've been working on. And we're really excited about that. I think Datadog's releasing a lot of new products that we're excited to try out and see how well they work in our environment. There are different levels of concerns at different places. In certain places, we have restrictions for security reasons. In other places, certain use cases might not match up with expectations, like I was kind of mentioning earlier. One example of this is our concept of environment. We don't have like one shared environment name across different places. A lot of times, like our AWS accounts are used as environments, so that doesn't play very nicely right now with IDP and things like that. So there are certain cases where we need to use our own proprietary solutions for this, but we're absolutely we immediately want to try out Bits and see how much value we can add as well for these use cases. I think it's like the more that we can leverage our vendors, the more that can be simplified in one pane of glass, the more that can happen in Datadog. We love it. So we're excited to try it out, but there definitely is a lot of overlap in the related stuff. It's very similar in terms of, I think, the strategy and the types of things it's looking at, but yeah.
Thanks.
Thank you so much, Eric. Wonderful.
Thank you.